So my name's Dave Starling. I'm the CTO at Seenit, and I'm going to talk to you today about what we've been doing to change the way people think about video in large organizations using Couchbase in a number of different interesting ways. So what we're doing is helping very large organizations change the way they think about video, specifically storytelling video, video that is impactful and trustworthy. So typically this is with large organizations collecting content from their fans, their employees, their consumers. We think that the whole digital transformation piece that was talked about in the keynote this morning is key to what we do. We share a very common mission with Couchbase in that respect. Our whole process is to help our clients, very large clients like Rolls-Royce, HSBC, Unilever, to realize that every company now is a media company, whether they want to be or not. Everyone has to deal with video in some way or other. It's the most engaging way of handling engagement with your consumers, with your fans, and so on. And so what we're doing is we're helping them produce this crowdsourced model of content using mobile phones as the acquisition tool. So if you want to produce something for your consumers, if you're a retail brand, the people who tend to know your product best are your own customers. It's why Couchbase have people like myself come and talk to you guys about what we're doing, because it's the most realistic way. It's not cherry-picked. It really is how we're using it in production. And so we try and get that through in the same way with video content. So to give you some background on that, we've been around just over 3 years. We're a Python shop. We're 100% Python with a little bit of Node here and there for build processes. And on top of that, we're using RabbitMQ on Google Cloud Platform. And we were built from the ground up with Couchbase. So my background was in architecture using Couchbase in a retail environment. And so when I joined Seenit at the beginning, it was, right, okay, let's evaluate everything and work out what we need to do. And then I'm doing another talk later on with Google to talk to you about the evaluation process we went through in that. So if you're interested in Google's cloud platform and running Couchbase on it, then that might be interesting for you. So we're running 4.6.1 in production. We'll be on 0.2 next week. And then we typically are very quick with releasing. The moment we go GA, we'll probably release that within a week of GA. So how do we work? It's a co-creation platform. So you have your community, your employees. If you're a large organization dealing with employee engagement, transformation of values within a large organization, video is one of the most powerful ways to do that. And so we allow them to create what is called scripted user-generated content or directed user-generated content, which allows you to say to people, okay, we want you to capture this content from around the globe, but here's a rough guideline of what we want you to speak about. So introduce yourself, who are you, what do you do, where do you work, what's important to you as an employee. That then all goes into a central cloud studio and then edited to produce cloud videos. So there are a number of challenges in all of that area. And one of the most interesting things we're looking at right now is what we consider to be content intelligence. So what makes content interesting to use? What content is good to use depending on how you're distributing it? So if you're distributing to Facebook, maybe different attributes are more important to you than if you were distributing it on Yammer or some internal internet system. So over time, you could be a company like the BBC who have tens of thousands of hours worth of content. You've built up content over time from a variety of different projects. So how do you handle that? So how would we allow them to exploit that over time? So a project that you run through our platform is not a transitory thing. It's not just a piece in time that might last for a few days. That's content that then can be used multiple times over the course of years. So how do we make sure that that content is still available to them in a relevant way? And then how can we evaluate, store, and search some of the non-obvious properties of that video content? So if you're a video editor and you're dealing with B-roll footage, you might not care about audio. So what we're now doing is looking at how can we evaluate audio properties, object recognition, label recognition, sentiment analysis. So I want people who are smiling within my content. We can now drill down to the frame level to find that video content. And then how can we extract the intelligence from all of that? So if we've got all of this exciting metadata about a specific video and a library of videos, how can we apply intelligence to that so that search becomes more relevant than just TF-IDF or recency or some other arbitrary scoring? How can we actually extract intelligence and make sure if I search for something that it will produce the most relevant result for my context? And then how can we visualize that data in meaningful ways? So if there's something interesting, you want to look at trend analysis or themes, what sort of are the most important things to your business to evaluate, then we can start to do some really interesting things. And I'm going to go through now some examples of actual practical nickel that you can apply to data sets. They don't have to be around video, but they might be interesting for you to try. So we do all of this through machine learning. We use a platform called TensorFlow, which is Google's open source neural network system. It will do lots of nice modeling. It runs in the cloud. You can run it on GPUs. Google have now launched their TPUs, which are the TensorFlow processing units. And there are several ready-to-use models that you can start working with straight away. So video, image and audio processing, natural language. So we take a video in, we rip out the audio, we send it off to be transcribed. That transcription comes back to us, and then we say, okay, now we're going to process it and extract sentiment and salience from that, so we can work out, if I've got this person talking about X, Y, and Z, I want to know how important X, Y, and Z is to that process. It's a fully managed service, and it talks Python natively, and everything is JSON. So it fits very well into the whole Couchbase way of doing things. It is very much a marriage made in the cloud. So then how do you look at searching for that video content? So for a fast turnaround of video content, you're doing same-day turnarounds, sometimes even same-hour turnarounds. You've got 600 people contributing video content, so that's potentially several hours worth of footage. How do you allow a video editor to reduce that down to the 5 or 10 seconds that they need for a specific piece of the shot without having them watch all of that content? So we've been looking at ways of drilling down search to allow you to get it to, right, I want 5 seconds of someone saying hello while smiling in front of a sunset. And ideally, that would then give you the specific set of videos for your use case, depending on where you're distributing it. So, like I said, these large video libraries make it hard to find the right clip for what you need to do. And sometimes if you've got 5 hours worth of footage, you actually only need 2 seconds of that video for the cut you need. So here's a little look at our one of our architecture models. So hopefully you can see this, but I'll talk through it. So we have content ingestion on the left. Content ingestion is typically people shooting on their mobile phones, but it could be from professional cameras uploaded through a web uploader. And that content then goes up into Google's cloud storage. That then gets put onto a set of task queues. We use RabbitMQ, but you could use a pub/sub system. And then that's split into a number of different parallel pipelines that then process and store the data in Couchbase. This is all elastic, so we monitor queue depth, and then we will very quickly add new machines to that instance group to say, okay, to keep our SLAs with our customers, we're going to fire up 10 new machines, all with 32 cores, and potentially even GPUs attached to them as well. So that then goes into a number of different parallel processes, some of which is video transcoding, but for the purposes of this piece, we're just going to focus on the metadata attached to that. So vision, speech, natural language, and other machine learning. And then the outputs of that go straight into Couchbase and indexed. So let's have a look at some practical nickel for how this can be used. So if I've got a set of documents, each with a list of tags and other attributes, how can we visualize them and make them interesting for non-technical people to evaluate? How can we analyze these? and how can we search these? So how can we extract some intelligence and meaning from them, and how can we make those searchable so that, again, a non-technical person can go through that content and work it out? So a couple of weeks ago, I did a talk at Google Next in London, and the day before, we asked all of the attendees to download the Seenit Capture app and submit content from throughout about what their key takeaways were, what some shots of people speaking, some just general scenery shots, and this is some of the content that we got from them. So it's a real mixture of content, and a typical shot might have something like this as a list of tags that have come back from our machine learning algorithms. So in this case, someone has filmed someone speaking, so it could be me up on stage, and it's picked up these tags as being something that would be, we think, appropriate to that video. So some obvious ones: performance, presentation, projection screen, speech. I'm not going to sing, but song would come up there because I could potentially be holding a microphone, LED display, really granular stuff if necessary, but we can expand on these quite easily. And with all of that, we get a level of confidence, so we, there'll be other things that could be in here, but we're not as confident that they exist. So depending, it could pick up beard, it could pick up glasses if I'm wearing glasses. It can be really specific about that. So if we've got a list of tags, and this could be a list of tags that are appropriate to video, it could be anything. And then we can do some fun visualizations with that. So this is a really simple nickel query, but it's using unnest. So unnest is one of those nice nickel query pieces that you can take and do some fun things with. So all we're doing here is we are pulling out all of those tags into basically a separate document, which is what unnest does, group them together by those tags and count them. So this is across our entire document set. And then we can put a threshold on that. So you could say, I don't care about tags that only occur once or twice. I only want really the most important tags from my group. So I'm outputting the name of the tag and then how many times that tag occurs within my set of documents. So then we can do some nice things like this. So this is just a word cloud. So this is actually just a jQuery JQ cloud, I think it's called, and that will take a set of a dictionary of words and counts, weights basically, and then produce a nice display for that. What we then have is actually you can click onto this, and I'll do a live demo of this. You can click on these and then have that search behind the scenes and then show you actually what other searches might be appropriate for that, and some fresh content that will show you, okay, if I click on stage, I want to get all of that content that's coming back for stage. But what if we've got some unstructured text, so it's just a string, basically. So here we've taken the transcription. It's not really anything we can do much with, unless we use some nice little nickel in there. So this is exactly the same thing as the tag query, but what we're doing is we're using the tokens function within nickel to split those out. So tokens will basically split out your content into all of the different words by taking the space as your separator. So what we're doing here is we're basically saying, I want to fetch all of, I want to separate out into new documents all of my words that are in there, but I don't care about documents where the transcription length is 0, so if it's an empty string. And I only care about words that are longer than something I define. So I don't want to get lots of ands and thes and so on. So I can set a minimum word length of, say, 5, group those together. I can also have a threshold function. So using having, I can then say I only want words then that occur more than a certain number of times. So then we get a very nice thing here, and actually this was a talk that I was doing at a Google event and in London, and the number one word fortuitously was Google. So hopefully if we did something similar at an event like this, Couchbase would come up, New York might come up, and so on. So we can then start to look at things like sentiment analysis. So this is where things get a little bit more complicated from a data modeling perspective, but it really is still quite simple for us to query. So sentiment is basically a polarity measure. So -1 means that it's really negative, and +1 means it's very positive. And then the magnitude is really how positive. So do I really love something, or do I just kind of love it? And so if I say something like, I really like working with Couchbase and enjoy talking about the work we do with it, that's going to pick up a positive sentiment that's quite strong. But it's also going to pull out an entity from that. So in this case, the entity is Couchbase. Behind the scenes, we've recognized that that is an organization. And then the salience is really how important that word is to that sentence. So is it what I'm actually talking about, or was it just said in passing? So now if we've got this nice document talking about video analysis, we've got all of these things in there. So we've got this, we have a type, which is your typical document describer in Couchbase. Transcription is just a string, a set of tags, and then this sentiment and entities block. How can we then start doing some interesting things with that and searching it? So we start off with selecting our content. And then because we're using Nickel, we can then basically use a pathing system. So you just do dot. So sentiment.polarity is greater than 0.5. So I want to find everything where people are talking positively about something. But I also want people who look happy. So I want to know that there's a face in there, and I want to know that they look happy. So I can then use the any in satisfies method for searching arrays within Nickel. And then this is where it gets a little bit more complicated, but it's really not. It's basically saying, and then I want to find all of the entities within the within that are organizations, and where any of those is called Couchbase. So I'm going to find everybody who looks happy, who is talking about Couchbase in a positive way. So then that gives us a really nice, simple Nickel query to do some interesting things with arrays and so on. But if we want to get a little bit more complicated, we can use things like, which allows us to do wildcarding. But like is case sensitive. It doesn't tolerate typos, and it doesn't exclude stop words. So even though we can look at length, they're not necessarily stop words. So we might want to do something more more advanced to make that search more important. So this is where FullText Search comes in. FullText Search is now getting quite advanced within the Couchbase world. So we've been using it actually in production since about December, and we've had 0 problems with it. We've gone through the various transitions from ForestDB to Moss, and I'll give you a live demo shortly so you can see how that all works. But it offers some really nice things that you would expect from a basic full-text search engine, but done in the Couchbase way. So it's all done through your SDK, so it's very, very simple for your developers to pick up. If you're a developer, it's very easy for you to work out the methods or the functions that you're going to need to use. And so it will do things like word stemming. So if I'm talking about, if I search for water or I search for waterfall, I'm going to get a similar set of results. So it's going to basically say, okay, if I search for waterfall, it's going to trim that down to the stem of that word, which is water. So waterfall will still come up highly in those results, but water will also then go down the list later on as well. It has multi-language support. That language list is growing over time, but it means that you're not just limited to English. You can do fuzzy searching and prefix searching. So fuzzy searching says, I want to search for this word, but I'm okay with this letter being slightly off by a certain amount. And prefix searching is basically a wildcard at the end, but very fast. The results you get back, it will give you the snippets, so the actual content that is relevant to your search results, and then highlight those as well, so you can opt to get some nice HTML wrapped around your results to allow you to display them nicely, so you know this is why it matched against this result. The default scoring is what's called TF-IDF, which is term frequency inverse document frequency. It's basically a way of defining a relevance for what you're searching for within the whole set of documents for that document itself. So if a certain word only is an important word and only appears in a document once, but is across your whole set not very important, then it won't rank as highly. There's a really good website if you want to know more about how that works, because it's quite a complicated topic in itself. But fortunately, there is custom sorting now in the latest releases of Couchbase as well. Conjunction, disjunction, and Boolean queries I'll talk more about, but they allow you to combine a number of queries into one and do some fun things with that. Custom sorting basically allows you to sort by field. So this was released in 4.6, and it will allow you to say, okay, scrap the default scoring method. I want to order by date, or I want to order by my own ranking. And you can also boost. So when you're combining these queries together, you can boost certain words. So if I've got first name and last name within my document, and I search for a name, you can boost the surname, because you might say, okay, actually that's more important, because from a finding someone perspective, the surname is more unique. And you can also do faceting. So faceting is a way of describing the space of your search results in a different way, and I'll show you how that works later on. So to give you an idea of what advantages this gives you, we were looking last year roughly 12 to 15 weeks to develop our own search system. This was prior to FTS being launched in Couchbase at all. So we were looking at things like Elasticsearch, and it meant that, as a small startup, we didn't have a huge amount of resource available to us. We didn't have large infrastructure teams, we didn't have site reliability engineers, we didn't have anybody who could do this stuff, really, except for me. So what we were doing is we were saying, okay, if we're going to do this, we need to go down Elasticsearch and use the XDCR adapter. So we basically put in, from a timescale perspective, 12 to 15 weeks to implement all of these different types of searches, and then worry about the maintenance of that implementation going forward as well. But when FTS was launched in Couchbase, we actually did that in really just a few days, because the Python SDK had support in there natively. It was extremely easy for us to set up indexing in our platform. There wasn't any infrastructure change that we were going to need to make. There wasn't any maintenance worry that we were worrying about. So we actually released these. I think I did them pretty much just over a weekend on a Saturday night, and released them on the Tuesday. And they worked, and they worked very, very well. And then after that, we were like, actually, you know what, there's all this other cool stuff we can do in there. So autocomplete search. So prefixing allows you to very, very quickly do server-side autocomplete. And then related searches, which are based off facets as well. And so really the hardest part for us was knowing when to stop that development, because we were sort of getting a bit carried away with ourselves, like a bit of a kid in a candy shop. So I'll do a live demo. Let me... Hopefully I can get this. There we go. Now, unfortunately I can't see that screen, so let me just switch over to mirroring, and hopefully that will... Okay, so quite a small resolution, but we will persevere. So here we have BBC Earth's content. So BBC Earth are part of the BBC. You will know them from Planet Earth, Blue Planet, those great shows that we've probably all seen. And they collect a number of different pieces of content from their communities. So they have a huge community engagement platform on bbcearth.com. And then they also have professionals within the Natural History Unit that shoot all of these shows, doing stuff and shooting it there as well. So they've got all of this great content, I think close to 10,000 pieces of content here. And we can try some searches and just see how the prefixing works and so on. So if I start to type sun here, so it's giving me content search results already, and it's giving me name results. So if I just keep typing, so I've searched for sunset, and it's giving me the top 3 results for what sunset is. And then I can go through this content and see which tags have come out from that. So here we have the tags of sunset, reflection, reservoir, nature, sky, lake, and so on. This is all produced on ingestion of that content. But what I also have is my related searches up at the top, if you can see that. Let me zoom in. So my related searches are basically the facets that have come back to me from FTS. So what it's doing is saying within your results set, here are the top 5 other tags that occur within that result set. So in our case, when we're searching for sunset, you would expect things like sky, horizon, dawn, sunrise, and cloud. So I can just click on these. Let's go for cloud. And I'll get a different set of results, but they're effectively related searches. Now, facets can be used in a number of other ways as well. So facets can be used for, if you're shopping on Amazon and you go into a category, it basically allows you to then continue down within your set of categories to say, okay, I'm looking at computers and electronics, and then you will go then into laptops because that's a relevant search for you. And then if we look at, let's do the tag cloud thing. So here they have a project called Small. So they did a project, a call out to their community online to say we want everything that is small. So someone's uploaded Bambi, some flowers, some spiders, and so on. So let's go to the tag cloud, and this is all a live nickel query. So then naturally you would expect this type of result set. So macro photography, nature, fauna, flower, and so on, insects. So now if we click on insect, we will get some nice insects come up. That's this is the most recent content that's gone up. And then you can also start doing more abstract things. So green. You don't have to do it as a specific thing. You can just search for green, and you get scenes that are green. So again, from an editor's perspective, this is something that can be really useful for you for setting a theme or setting a scene within your content. So let me go back to my presentation. So how does this work? So working with FullText Search is really, really simple within the Couchbase web interface. It's even simpler now in the 5.0 beta, but even in 4.6, if you want to try that out, it's very, very simple. So you start by determining what you want to search. So if you've got a set of user documents and you want to search by name and email address and so on, then you look at your document type. So you've probably got a document type called user, and then you search that within a bucket. So an index is always against a bucket. You choose the fields that you want to search. So typically it's going to be name, but maybe you want to search for address, email, and so on. And then you create an index and you search it. It really is that simple. So we'll go through some types of query that you can run against that, and then we'll look at a real live example of how an index looks within the UI. So there are many. There are more now. So there's some really cool stuff coming up in 5.0. So the ones we use is a match query. So this uses the analyzer that you've specified for a field. So an analyzer will basically allow you to define how the stemming for that works. So it could be that you're using the English language stemmer. It could be that you're just doing a keyword analysis, which won't do any analysis of the word. It basically just passes it straight through. There's a match phrase. So this is where you can do boosting on phrases as well. So a match phrase will basically allow you to specify a number of words, and it will match against that phrase. So it won't do any splitting of the words, but it will remove stop words for you. And then prefix. So this is where it gets good for autocomplete and auto-suggest. But there are lots more. You can do even regular expressions, Boolean queries, wildcards, and now there's a lot of geo-search capabilities in 5.0. So if you're storing lat long coordinates for content as we are, you can now drill that down and say, I want to find photos of people or videos of people talking about Couchbase positively, but within New York City, and you can specify a bounding box for that with lat long coordinates. And then you can combine those all together into what are called compound queries. So this allows you to say, okay, I've got all of these queries together, I want to bundle them together and then do some interesting things with them. So a conjunction query will basically say, I want to match X, Y, and Z, and the documents must match X, Y, and Z, and it must match all of them. So if you've ever done a Google search and put a plus in front of your search terms, that's the equivalent of that. So you're basically saying the search results return must contain these. A disjunction query is similar, but you can specify a threshold. You can specify, okay, I've got 5 queries and only 3 of them need to match. And then the Boolean query allows you to do a similar thing, but you can say it must contain these. Ideally, it should contain these, and it must not contain these. So it allows you to exclude data if you want to. So let's go through some practical index tips for full-text search. So you'll have a type field. When you create an index, there is a default type in there. Disable that, because otherwise it will index every document in your bucket, and you probably do not want that. So disable the default type mapping. In 4.6 onwards, you can also specify type mapping through document IDs. So if your document IDs are named in such a way where you might have user dash XYZ, then you can use that instead of a type field. Then you create the child fields for everything that you want to search. So you can specify name, address, email, and so on. You specify each of those as the fields that should be indexed. And then if you want to, you can also add multiple indexes for the same field. So you might have a keyword. So let's take the name field. You might specify an index field on that is a keyword. So matches against that will be exact matches. You can then also specify as a standard or English analyzer, and then that will take it and stem it if possible. You can then boost that, so you can say, I want exact matches to appear above anything that is a match through the stemmed analyzer. So that's a nice way of prioritizing exact matches. And then you can nest multiple disjunction and conjunction queries together into a Boolean query. So you can say it must contain all of these, and it should contain some of these. So this is a really good way of doing multi-tenant data searching. This is probably a little bit too small for you to see, but you'll be able to download the slides afterwards, I believe. So this is a reasonably complex index that we've created. So it's searching for uploads. We've got tags in there as a keyword. So that's searchable as a different name, tag terms. It's a keyword search. And then we also have tags in there again as using the standard analyzer for this index, which in this case is an English language analyzer. So what that means is we can search for tags and prioritize those that are exact matches versus those that are not exact matches but still relevant. So what's returned? So you get what a typical Couchbase return would be. It's JSON. We're Python internally, so that comes back to us as a dictionary. And then you get a list of document IDs and their scores. You get then optionally the match locations. You can request fields to come back that are stored in the index. One other thing you can do as well is you can add fields to your indexes, but not have them indexed, they're just stored. So this allows you to do the equivalent in FTS of what cover indexes do in Nickel. So you don't have to go and fetch the document afterwards. You can just use everything that comes back in the results. It's much quicker that way. And you can also do pagination very easily because you get the total result set. You can limit the results that come back. And then you can just say, okay, this is 1 to 10 of 300. So in terms of Python code, this is really simple. So I've got a queue, which is my search term. I've got match queries, which I'm creating as an empty list. And then for each of those terms, I've split it by space. So if I search for Couchbase in production, it will split those words into a list. And then for each of those items, I can create a prefix query for my email, a prefix query for my name, and boost it because that's more important than the email. and then I can do a match query and boost that even more, because a match for us is more important than a prefix. So if I search for Starling, then Starling will be boosted more than if I'm searching for star. That then goes into a disjunction query, so it's basically saying any of these is okay. So I want a number of these. And then I just pass that through to my Couchbase connection object, define the search index that I have created, pass a query through, and any other parameters that I might want to specify. So parameters that you might pass through are the fields you want returned, or any facets you want returned, and they will come back in your result object. So then you can combine all of these together into something quite grand, which is useful for multi-tenant data sets. So if you've got some a database full of different customer data, and you only want your customers to search within their own data sets, you can do this. So you'll have a tenant ID, you'll have a client name or a client account ID or something like that. So you can create a field within your index that is a keyword analyze field, and it will then only define exact matches for that. So you create your normal search, so a match query, match phrase, whatever, and then as many fields as you want in that. So that then becomes a disjunction query. So then a disjunction query is basically saying, any of these, some of these will be okay. And then you've got this, so you've got this keyword field, and then you can use what's called a term query, which is the exact match. So it's not going to do anything beyond looking at saying, does this equal this? There's no processing going on there. So I'll say then, where account equals Couchbase, that comes into another disjunction query, and then we combine that into a Boolean query. So we have a Boolean query where we're saying the must fields are those of my account name, or names if I want to search across multiple content areas. And then the should is my original disjunction query, where I'm specifying the actual search itself. So this is all done in code. So you're not letting your users define their own search parameters. You're defining the way that you think that your data should be searched. I've got a few minutes left, so I will talk quickly about faceting. So faceting basically allows you to create that set of aggregate data for your result set. So how much data comes back with these types of other searches that we think are going to be relevant. So really, it's, for retail, it's going to be very useful for defining the way your categories or catalogs are going to sit. But you can also do things like related searches, which is what we use it for. So you can then do term facet searching with that as well, which is probably a little bit more out of the scope for what we're going to talk about now. But then you can get, basically what you can get is the top number of tags, so the top 5 tags within your result set, and get some interesting visualizations going in that if you want to. So thank you very much.